Hello friends, as I remembering this is the 7th lecture of this graph playlist. In this video we will discuss about BFS, that means breadth first search. This is the another traversal in graph, which is something different from depth first search, that means DFS. Okay, let's let first some a small example so there is some clarity about BFS. If I try one example, so there is basic understanding. If one graph is like that, one and surrounding is 2, 3 and 4. Okay, and after that 5, one is 6, another is 7 and 8 also. Okay, if this is the graph, okay, then there will be many answer are there. If you follow BFS, if you follow BFS, the one combination which is right will be that. That means first we take one, that means this is the center. Okay, and then you will take all the neighbor from this center which is at a unit distance. That means from 1 you 4 is at unit distance, 2 is also the neighbor, that means unit distance, 3 is also the neighbor. Okay, so next you will take 2, 4 and 3 in any order. Okay, either we first take 2 then 3 then 4, but um, 2 4 3 will be taken after 1. Okay, if 1 2 4 3 all these 4 are taken, then after you will take the element just neighbor of 2, that means 5, you will take 5, and the neighbor of 3, that means 6, neighbor of 4 8, neighbor of 4 7. That means this is one at 0 distance from center, these are the 4 2 and 3 are the 1 distance from neighbor, and after that you will take those node which is at 2 distance from neighbor, that means 1 2, that means you will take 5, 1 2, that means you will take 6, 1 2, that means you will take 8, 1 2 you will take 7. That means if you take 1 2 3 4, then after you will take 5 7 8 and 6. Okay, you can take 5 7 8 6 in any order. You first take 5 then 8 then 7 then 6. No, there is no that. This is also right, you will take 5 8 6 7. It's right. But first you should take 1, then after you must take 2 3 and 4, and if you solve 1 2 3 4, then after you will take 5 6 7 and 8. Okay, that means 0 is at center, that means 0 distance from center, all these are at one distance from, or at one distance from center, then after these are 5 7 8 6, these are at two distance from center. So the if you follow BFS, then the answer one combination should be 1, then 2 3 4, then 2 3 4. Okay, and then after you 5 6 7 8, you can take in any order 5 6 7 8. You can take 5 6 7 8 or 5 7 5 7 8 6. You can take like that also, and you can, if second combination you make, then you can write like same as like 1 2 3 4. You can take, you arrange all combination 5 7, that means you can take first 5 then 6 then 7. Okay, and then 8, but this one should be at first, and then these 3, that means 2 3 4 will be after 1, and 5 6 7 will be after 2 3 and 4. This is the correct BFS traversal. Okay, so I think there will be some clarity about what is BFS. Okay, that means if you start from any node, you can take any node at a root as a center of, from that center you first try to cover all the nodes which is at one distance. Then after you will try the elements which is at second distance, and after that you take all the nodes that which will be at third distance from center. Okay, so I think you have some understanding after that example. Now if you try from 0, this is the same this is the same example that I have taken in DFS. Only difference is I have rotated. This is the same example that I have taken in BFS, sorry, in DFS. Difference is only in this example I rotated this graph. I have taken this, okay, in previous DFS example, but for simplicity, so that treated or look like a tree. So I start from 0 and go towards the left child, right, or other all child. I have to rotate this, okay. So there is no difference. Example is same. Now I start from for in BFS there must be need of queue, okay. So if you are a beginner, and listen carefully that queue will be used in BFS traversal. It is similar to the level or the traversal in tree, okay. So one queue will be used to solve this. That this is queue. You know queue is first in first out, okay. This is queue. This is queue first in first out, okay. Let us start from 0, and there will be also one visited array, because in traversal there is no need to revisit any nodes again and again. For this purpose you will take one visited array of the size of this array will be number of vertices, okay. 1 2 3 4 5 6. Okay. This is visited array, indexing 0, best indexing, because here vertex is 0 best. 1 2 3 4 and 5, and this is unvisited, so start and tick. And if I start from 0, then if you start then tick 0 and make 0 visited of 0 1, and put this 0 in this queue. That means queue is, if any element, that means if 0 in queue, that means 0 is visited, okay. So you cannot revisit this queue. If you are at 0 now, that means queue is filled with 0. Now let's start. First, um, delete the delete queue element, okay. And all the neighbor which is unvisited will be added in queue, okay. If you take 0 and added in queue, then then delete this 0 and all the neighbor which is unvisited. The neighbor of 0 is what? 2 and 1, 1 and 2. So take 1, take 2, sorry, take 1 and check 1 is unvisited, yes. If this neighbor is unvisited, then make neighbor is visited and tick also and add in 1, okay. Now what is the neighbor of 0? Another is 2. So make, or here check, is 2 unvisited, yes, is 2 is unvisited, so make this visited, that means 1, and put this value in this 2 in queue, and also tick this 2. So that means, and 0 0 1 2. If you try to store this, if you try to store this 0, if you remove from queue, then make add you in list. Let's assume this is list for resulting purpose. This is list. So try to add. After removing, you must add in list. Now here if you remove one next element, then one will be removed and put this one in list. If you remove one, then after that you have to find all the neighbor of one that is unvisited. The neighbor of one is 0, 3, 5, 4. You try for 0, but 0 is already visited, so you cannot add or take 0. Now you can take 3, 5 and 4. Let's try for 4. 4 is unvisited, okay? If 4 is unvisited, make visited and tick and add 4, okay? Add 4. Now another neighbor is 5. Check for 5. 5 is unvisited, okay? So you can take, make visit, tick this 5 and add 5 in queue. Similarly, another neighbor is 3. Check for 3. 3 is unvisited, so we can visit it, add it 3 in queue and make tick or tick it, okay? Now you follow queue. So if you remove one next element from queue, then 2 will be removed, okay? And if 2 will be removed, add this 2 in the list and check for the all the neighbor of 2. The neighbor of 2 is 0 and 3. Check for 0. 0 is already visited, so we cannot add 2. So we cannot add 0, okay, sorry. And the another neighbor of 2 is 3. Check for 3. 3 is already visited, so we cannot add, okay. Now now then we remove one next element. That means if we remove next element, then 4 will be removed because this is first in first out, FIFO, okay. The element which is added first will be removed first, so now 4 will be removed. And if 4 will remove, add this 4 in the list and check all the neighbor of 4. The neighbor of 4 is 1 and 5. Check for 1. 1 is already visited, so no need of for 1 to do anything. Now check for 5. 5 is already visited. If you check for 5, 5 is already visited, so you cannot add 5, okay. So the next step is remove next element. If you remove next element, then 5 will be removed. Add this 5 in the list and check for all the neighbor of 5. All the neighbor of 5 is 1 and 4. Check for 1 is already visited, so we cannot do anything for 1. Another neighbor of 5 is 4. 4 is already visited, so we cannot do anything, okay. Now if now remove next element, then 3 will be removed. Check and add 3 in the list, okay. And check all the neighbor of 3. The neighbor of 3 is 2 and 1, and 1 is already visited, so we cannot do anything. And the neighbor of 3 is 2. 2 is already visited, so we cannot do anything. Now we try for another remove, but here queue is empty, so we cannot remove anything, okay. So we try to remove each element from queue. We try to remove one element from queue until this is not vacant. If this queue is already vacant, then your step is covered or done. And if you see this list, then you see that all the nodes are added in the list, okay. 0 1 2 3 4 5, 0 1 2 3 4 5. So this is the BFS algorithm. Now for practice, I have taken one GFG practice, so clearly understand BFS algorithm. You can also try before seeing this solution, okay. So in this solution, I will follow the same steps that I have discussed in this lecture. First, take one visited array and one queue, okay, queue of integer and one list, so that list will store the answer for all nodes. Like first one visited array int visited equals to new int the number of size of this visited array of node size, that number of nodes or number of vertex, okay. And 0 is already filled because in Java if you don't fill any, then array will be filled with 0, okay. Now make one queue queue of integer. Name this queue as queue equals to new array dq. You can take new array list, sorry, new link list also. Queue equals to new array dq or new link list. Link list will be okay. I am saying that you can write at the place of array dq. That means you can replace array dq with linked list. But the difference is that if you declare new array dq, then null is not. That means null will. If you declare new linked list, then null value will be add. That means null value is accepted in queue. Okay. So new array dq. Okay. Now we have taken visited and queue, and let add first element, that means 0, and make 0 as visited. Now queue dot add first, any you can add any 1 2 3, but for simplicity I will add 0 and make this visited of 0 equals to 1. This visited 0 indicates that 0 is all. Remove all elements, that means you remove next. So will queue is non-empty, that means queue dot size. If queue dot size greater than 0, that means queue is non-empty, you will remove. Okay. Int node equals to queue dot remove. That means this is the remove node. Okay. First remove 0, then if you remove 0, then the neighbor of 0 is 2 and 1. So all the neighbor of 0 will be attempted to add in queue. That means if you remove 0 from queue, the all the neighbor of 0 will be checked, and if this is unvisited, then this will be visited and added in queue. So for all child, that means int I equals to 0, I is less than, make this addition name as graph, because I like name as graph. You can name any. Okay. Graph dot get. This will get node. That means if this will give the array list in correspondence to this node. Okay. Dot size I plus plus. Okay. Now this for loop give all the neighbor, all the child of this node. So int child equals to graph dot get of node dot get of I. This child, that is for every child, you first check if child or neighbor, if visited of child equals to 0. If the child is or neighbor is unvisited, then you will add this child in queue and make visited of child equals to 1. Then add, that means queue dot add equals to child, and make visited of child equals to 1. Okay. And if you remove elements, then answer will be stored in list. Okay. Then list dot add list, sorry, list list dot add parts node. This and make one. Here you will remove, you return, here you will return array list. Okay. So make one array list that will store all the nodes, so you should return this list. Okay. For that purpose make first array list of integer list equals to new array list. So this is the code. All visited array and queue tq and or you will remove until queue is non-empty, and finally we will return list that will store all the nodes. I have followed the same algorithm that I have discussed in lecture. Show one error 39. Okay, array list, sorry. Okay, let's try. One test case is passed. Try for all test case. Okay, yes, done. So all the test cases passed. So this is the code for BFS, that means breadth first search reversal. Next video, a small video, will discuss about time complexity. Okay, thank you.